Welcome back to the deep dive. We are doing something a little different today. And I want to start with a bit of a visualization exercise.
Okay, I'm game.
I want you to close your eyes for a second, unless you are driving, of course, then
Yeah.
please keep them on the road. But I want you to imagine an AI,
All right, picturing it.
but not the kind we've all been playing with for the last couple of years. Not the chatbot that just sits there, like a digital golden retriever panting, just waiting for you to throw the ball.
Waiting for a prompt.
Exactly. I want you to imagine an AI that never sleeps, it never forgets a single conversation, and most importantly, it doesn't wait for you to tell it what to do.
Yeah.
It actually anticipates what you need before you even realize it yourself.
We're talking about the real holy grail of automation here. That shift from reactive tools to genuinely proactive agents that can actually drive the workflow.
That is the word, proactive. And that's why today we're diving deep into a framework called memU, which is from a company called NevaMind-AI. And if you comb through their documentation, which we have, they describe it as a memory framework built specifically for, and this is a quote, 247 proactive agents. They even list examples like moltbot or claudebot.
It's such a fascinating pivot in the industry. We've spent all this time marveling at LLMs that can answer questions with, incredible fluency, but they've always had this one fatal flaw.
The memory of a goldfish.
Exactly. So today's deep dive is really about how we bridge that gap, how we get from a simple chatbot to an agent that has a continuous, evolving memory.
And the stakes are actually pretty high. This isn't just about, a smarter Siri. The mission here is to unpack how MEM technically achieves this idea of predicting user intent, but maybe more importantly, how it stops these always-on agents from completely bankrupting you.
The elephant in the room, the server costs.
Right. So let's start there with the core problem, because I think a lot of people just assume AI is magic and, free. Why can't I just leave my ChatGPT window open forever? Why do we even need a framework like this?
It really comes down to the fundamental architecture of LLMs. They are what we call stateless.
Stateless. Okay, let's unpack that for everyone.
It means that every time you send a message, the model has completely forgotten who you are. It gives you the illusion of a conversation, but what's happening behind the scenes is your app is sending the entire chat history back to the model with every single new message.
So it's like meeting someone with amnesia every 5 seconds, and you have to hand them a transcript of your entire friendship just to get them to say hello back.
That is a perfect analogy, and that's exactly where the meter starts running.
Because of tokens.
Precisely. You're paying for tokens, which are basically little snippets of text. So if you want an agent to remember weeks of context, you are feeding it a novel's worth of text every time you ask a simple question. It's just...
Yeah.
It's incredibly inefficient.
It's like having to read someone's entire biography every time you want to ask them for the time.
Yeah. And that's why memU is pitching itself, first and foremost, as cost-efficient. They talk a lot in the docs about reducing long-running token costs by caching insights.
Caching insights.
That's the key unlock. Instead of asking the main brain, the LLM, to reread the whole book every time, memU acts like a really efficient executive assistant just taking notes. It captures the insight once, stores it somewhere cheap, and only pulls it when it's needed.
But it's not just a database, right? Because a database is passive, it just sits there.
What really stood out to me was this idea of the proactive shift. I actually highlighted this one sentence. Even without a command, the agent can tell what you are about to do and act on it by itself.
And that's the differentiator. Most memory systems are basically just storage lockers. You put a memory in, you take one out. memU is trying to build a brain that actively processes those memories to predict the future.
Which sounds borderline telepathic, or, I don't know, a little intrusive maybe.
Well, it's really just architectural. It's about moving away from command and control, where you drive the bus to a model of observation and anticipation.
Yeah.
So let's break down how that actually works, because anticipation feels like such a human thing. The docs lay this out in a proactive memory lifecycle. It's a 5-step loop.
Right, and understanding this loop is key to understanding how this thing thinks. It starts simply enough. Step 1, user initial query.
The trigger, I ask a question. Simple enough.
Then step 2 is agent planning and actions. The agent looks at your query, maybe grabs some relevant memories or documents, and figures out how to respond.
Okay, still feels pretty standard. But step 3 is where it seems to start diverging. Memorize and update Toto.
Yes. In a normal chatbot, the conversation ends when it gives you an answer. The loop closes. Here, the answer is just more data. It takes that interaction, extracts an insight like, oh, the user's interested in Python scripts, and stores that. But it also updates its own internal to-do list.
So it's constantly modifying its own agenda based on what I'm doing.
Which leads directly to step 4, which I think you're right is the secret sauce. Predict user intent.
This is the part that feels wild to me. It says it anticipates next steps and proactively prepares relevant context. So, okay, practically, what does that mean? Let's say I ask for a quarterly report. A normal AI gives it to me, conversation over. What does memU do?
So memU gives you the report,
Yeah.
but its internal monologue is something like, okay, historically, when he asks for the quarterly report, the very next thing he asks for is a comparison to Q3. So while you're reading the report, it is already prefetching the Q3 data in the background.
It's loading the chamber.
It's loading the chamber, exactly. It's preparing that context before you even ask. And then step 5 is simply the loop. It goes right back to step 2, creating this self-sustaining, agent-driven workflow.
Wow. It just completely changes the dynamic. It's like the difference between a junior employee who waits for instructions and, I don't know, a chief of staff who hands you a coffee because they noticed you yawned and a briefing minder because they know you have a meeting in 5 minutes.
That's a perfect analogy. And here's the technical catch. You can't do that if your memory is just a big, messy pile of text. To support that kind of intuition, you need structure. And memU uses this hierarchical architecture to manage it all.
I saw the diagram for this. It's a 3-layer system, resource, item, and category. It reminded me of a file system, but it seems more alive.
Think of it like a library. The bottom layer is resource. This is the raw data, the books on the shelves, your chat logs, uploaded files. This is just ground truth.
Okay, raw storage. Got it.
Then in the middle, you have the item layer. This is for targeted fact retrieval. It's like pulling a specific quote from one of those books in real time. What's the user's phone number? Or when is that deadline? Quick fix.
And the top layer is category.
The category layer is the high-level summary. This is where the mind of the AI organizes itself. And what's fascinating is that memU claims this enables auto-categorization.
Meaning I don't have to manually tag everything?
Exactly. New memories just organize themselves. If you start talking about gardening for 3 days straight, the system automatically creates a gardening category and clusters those insights. And this is what allows for pattern detection. The system can see recurring themes without you explicitly saying, hey, I'm into gardening now.
It sees the forest, not just the trees.
Precisely. It builds a map of your habits and your interests.
Okay, so we've got the loop and the hierarchy. That's the how. But I want to talk about the so what, because hierarchical memory architecture is a great buzzword, but I want to know what it feels like to use it. The docs have these proactive scenarios that I thought were really telling.
Yeah, those are great. Which one stood out to you first?
Let's start with scenario 1, the research assistant. They call it information recommendation.
Right. So in this one, the agent is just silently monitoring your reading history, your searches, and knows what you're researching.
And the example isn't just, here's another paper on your topic. Any search engine can do that.
No, it's way more contextual. The example they give is, I found 3 new papers on RAG optimization. But then it adds the kicker. One author, Dr. Chen, you've cited before, published yesterday.
That's the part I loved. You've cited before.
I mean, that implies so much happening in the background. It had to see the new paper, pull the author's name, cross-reference that name against your entire library of past citations, and then understand that this connection means it's high value to you.
It's filtering the noise. It's searching the web through the lens of my specific history. It knows who I trust.
It essentially turns the agent into a productive filter bubble. It saves you time vetting sources because it already knows your vetting criteria.
Then there's scenario 2, the financial guardian. This one felt, honestly, a little high stakes. I'm not sure I'm ready to trust a bot this much, but the capability is just incredible.
The trading and monitoring scenario, yeah.
Right. It says the agent learns your risk tolerance. And the example was the agent alerting you. NVIDIA dropped 5% in after-hours trading.
But again, look at the proactive layer. It's not just a news ticker. It then says, based on past behavior, you typically buy tech dips above 3%.
And then it does the math for you. Your current allocation allows for $2,000 additional exposure while maintaining your 70-30 equity bond target.
And if we tie this back to that whole cost versus continuity problem, think about the cognitive load that saves.
Yeah.
The AI had to correlate a real-time event, the stock drop, with a static rule, the 70-30 split, and a behavioral pattern buying the dip.
To do that in a normal chatbot, you'd have to write this massive prompt every single time. Here, it just knows.
It creates a persistent state of awareness. It's like having a financial advisor who's completely obsessed with you just watching the market while you sleep.
Okay, and scenario 3 was the executive assistant email. Everyone promises AI email, but it's usually just better spam filtering. This was about tone and priority contacts.
Right. The example is something like you have 12 new emails, but instead of just a list, it says, I've already drafted 3 routine replies and flagged 2 urgent items.
And then the predict user intent part kicks in again. It asks, should I also reschedule tomorrow's meeting based on the conflict John mentioned?
That conflict John mentioned phrase is so subtle but so powerful. It means the agent read John's email, understood the meaning of a conflict, checked your calendar, realized you hadn't seen it yet, and is now suggesting a fix. It's just handling logistics.
It really is a shift from a tool you use to a partner you work with. But I want to go back under the hood for a second. To do all this, it needs to retrieve info fast. The docs mention 2 ways to remember.
Ah, yes, the retrieve
Yeah.
API. This is a super critical distinction for anyone building with us. You have 2 methods, RAG and LJAME.
Okay, let's break this down. Method 1, RAG.
So RAG stands for Retrieval Augmented Generation. But in memU, just think of it as fast context, millisecond speed.
And how does it work, basically?
It uses embeddings. It turns all your text into numbers like coordinates on a map. When you ask a question, it just looks for information that is mathematically close. It's very low cost because you're not firing up a giant reasoning engine. It's just a lookup.
So this is for real-time stuff, like, what did I say about gardening last week?
Exactly. Quick, efficient, almost reflexive memory.
And method 2 is LLM.
That's your deep reasoning mode. It's way slower. We're talking seconds, not milliseconds, and it costs more tokens. But this is what provides the intent prediction and query evolution.
Query evolution, what does that mean?
Well, sometimes users ask bad questions, vague questions. If you ask, what about that guy? RAG will probably fail. It has no context for that guy. The LLM method can look at the conversation history, figure out, you mean Dr. Chen from our earlier example, and then refine the search to get a better answer.
So it's the difference between a keyword search, which is RAG, and asking a librarian to actually research something for you, which is the LLM method.
That's a great way to put it. And you can mix and match. You don't burn money on deep reasoning when you just need a phone number. Use the cheap tool for the easy job.
And speaking of options, I noticed memU isn't locked into just one AI provider. You're not stuck in the OpenAI walled garden here.
Yeah, that's a big deal for developers. It works with OpenAI out of the box, sure, but the docs highlight support for OpenRotor.
Which means?
It means you can access models like Anthropic's Claude 3.5 Sonnet or others. You can set up custom profiles. So, for example, you could use Voyage AI just for your embeddings, the storage part, and a totally different model, like Quinn, for the chat part.
It's modular. You can swap out the brain parts.
Exactly. No vendor lock-in. And they cite a specific benchmark, the Locomo benchmark, where memU scores a 92.09% average accuracy.
Is that good? 92% sounds like an A-.
In the world of complex multi-step agent tasks where the AI can easily get confused or hallucinate, 92% is very robust. It shows that the proactive memory loop we talked about is actually reliable enough for production.
Okay, so if I'm a developer listening to this and I want to try it, how do I get started?
It's surprisingly accessible. They have 2 routes. There's a cloud version at memU.so for instant hosted use.
And for the people who want to run it on their own machine?
It's self-hosted. Good old pip install. You run it on your own infrastructure. They have a core API function, Memorize, that you feed everything, text, images, video, and it offers 0 delay processing. It's all built for speed.
So, zooming out, I think what strikes me most about all this is that we're not just talking about a better database. We're talking about giving AI a sense of continuity.
That's the word, continuity.
What does this mean for how we interact with computers going forward?
I think we're seeing the end of the blank slate era of AI.
Yeah.
Until now, every time you open a chatbot, it was like meeting a stranger, a very smart stranger who maybe read a dossier on you, but a stranger nonetheless. With frameworks like this, we're moving toward relationship.
A relationship through long-term memory.
Exactly. An agent that knows your history, your goals, your preferences. It doesn't just answer questions anymore. It starts to manage your life. The interaction becomes a partnership.
You know, there was one last example in the source material that I can't stop thinking about. It was almost a throwaway line, but it felt profound. The self-improving agent.
Oh, yeah.
That one. It describes an agent that monitors its own successes and failures to auto-generate skill guides for itself.
Right. It looks at its own logs and says, okay, I tried to get that data using method A, and it failed. Then I tried method B, and it worked. And then it writes a guide for itself so it never makes that mistake again.
That is, well, it's amazing, but it's also a little eerie, isn't it?
It raises a really important question. If an agent is constantly monitoring its own performance and rewriting its own rules, at what point does the agent understand the job better than the user who deployed it?
That's a thought to chew on. If the tool learns faster than the master, who's really in charge?
Indeed. We might be building the best assistants we've ever had, or we might be building our replacements, or maybe a little of both.
Well, on that slightly terrifying but also exciting note, we're going to wrap this deep dive. If you want to check this out yourself, look up the NevaMind-AI GitHub or their cloud demo.
It's definitely worth a look for anyone interested in where agents are going.
Thanks for listening, everyone. We'll catch you on the next deep dive.
Goodbye.